Hey guys, Mr. T here. Next video for 11 General Maths. This is going to be on compound interest again, but it's looking at what happens if you have different compounding periods. So this will help you with exercise 3C.3. So far we've pretty much assumed that interest compounds once a year, but in real life interest often compounds different periods of the year. So maybe half yearly, so if it was compounding half yearly, that would happen twice a year. If it compounded quarterly, that would happen 4 times a year. If it compounded monthly, it would happen 12 times a year. So compound interest, it uses the same formula as before, just a little more complicated, a little modified. So your formula for interest compounding a certain number of times a year, we're going to call it K, times per year, looks familiar, but K is injected in there in a couple of ways. So this is the compound interest formula modified to support different compounding periods. And you're actually better off just remembering this because it turns out to be the same as the compounding interest formula if you do it compounding once a year, because anything divided by 1 is going to be itself, anything times by 1 is going to be itself. So this formula, just like before, FV is going to tell the future value of the investment. This formula doesn't tell you how much interest is earned. It tells you what you end up with. You can work out how much interest is earned by taking away the principal, which was the starting value. PV stands for present value, but it's the principal in this case, the original investment. I is the interest rate per annum. So you always consider the interest rate per annum as a decimal here, because you deal with the fact that it's compounding a different number of times per year with the K underneath. So I is going to be divided by K in this formula, and then N here is times by K as well. N is the number of years in the investment that it's happening, okay? So what we're going to do is below, we're going to do a comparison between something compounding yearly, something compounding monthly, pretty much the same parameters as everything else, and you should see that it's always preferable to compound more often. So if we do compounding yearly, FV is going to be PV, the investment's 8,800, so PV is going to be 8,800 times by 1, plus the interest rate per annum is 4.8%. Needs to be as a decimal, so 0.048 divided by K. If it's compounding yearly, it's not going to happen once a year, so it's going to be divided by 1. And to the power of K times by N. Well, if it's compounding yearly, it's only going to happen once a year, so it's going to be 1 times by N. Compounding monthly, forgot that we needed a time period here, let's say for 5 years. So we need an N. So here it's going to be 1 times by 5. So it's going to be 8,800. 1 plus 0.048 divided by 1 is 0.048. 1 times by 5 is 5. So check that in the calculator. Do brackets and exponents first. So brackets 1 plus 0.048. 1 plus 0.048 to the power of 5. Now times it by 8,800. So that comes to approximately 11124.72. Final value of the investment after 5 years, 2 decimal places. So just for interest's sake, I wanted you to see what the investment's going to go up to if you compound it monthly instead. So you're still going to put the money away. You're still going to put $8,800 away in an investment for 5 years. The only difference is going to be 4.8% per annum. So it's going to raise by 4.8% per year, but the interest that you earn is going to compound 12 times a year because it's compounding monthly. And that's actually going to make a pretty big difference. 8,800. So now we're using the modified formula again, but it's going to matter this time. 0.048 divided by, if it's compounding monthly, K is going to be 12 because it happens 12 times a year. K is going to be 12, so 12 times by 5. So it's going to be 8,800, 1 plus 0.048 divided by 12. 0.004. And 12 times by 5, 60. So over those 5 years, it's going to compound 60 times. Yes, it's going to compound by a smaller amount, the 4.8% divided by 12, but simply because it's compounding 12 times a year, it's actually going to be a bigger final value at the end. So work this out, 1 plus 0.004 to the power of 60, 1 plus 0.004 to the power of 60, times by 8800, and that comes to $1181.64. So you see, even though it's compounding, it's all the same. It is still 4.8% per annum. It's still $8,800. It's still for 5 years. The only difference is it's going to be compounding, so loading on top of interest on interest on interest on top of each other 12 times a year. It is going to make sort of a bit under $60 worth of difference for the end. So it might seem small, but with larger sums, with bigger investments, that's going to be a massive difference. So hopefully that shows you how to use the compound interest formula with different compounding periods, and I will see you on the next video.